Okay, time to make some practice videos or time for you guys to practice. So if we're in class right now, I'd ask you guys to go ahead and try to find the absolute max and mins of number one here. Turn off the video, don't look, try to do the practice. I believe it's on page 116 of your notes. And when you're done, um, click the video on and I'll come back with some explanations. Okay, so if you're back, I assumed you gave it at least a shot. The question's really asking for all the numbers and for you to state whether it's an absolute max or min, a local max or min, or neither. So if you're looking at A, as far as, let's see if I can annotate here, and I'm looking here, that is the absolute lowest value. So it's going to be an absolute min. Okay. If you're looking at B, very confusing because my eye is drawn here. I want to call it a min, but they're actually, the value jumps. So at B, you're going to have a local max here. So that takes care of the first two. So you have an absolute min over at A and an absolute max at B. That's that closed interval method that we were talking about in the last example. For C, it kind of is just hanging out here in the middle. So for C, there's none. Let me get off of red. I don't like red. For part D here, now notice that looks at the bottom of a hump locally in this vicinity. In here, it's the smallest minimum value, so you can call it a local minimum. Again, it doesn't have to be absolute. To be absolute, it has to be the absolute lowest on the graph you're talking about. For R goes up here, and it looks like there's a, well, it looks like a kink here, kind of like an upside down absolute value function. And because this value here is the highest value, it is not only in the vicinity a local maximum, which is here, but it is also an absolute maximum because it is the highest maximum value on the graph. In other words, the highest Y value. Lastly, part S is above. It's not really in the, because for it to be a local anything, you got to be able to look left and right, but there's nothing over here. So again, you can't look both sides of this thing. It can't be a local anything. So it's not a local min, not a local max, definitely not the absolute minimum because A was the absolute minimum and R was the maximum. So we're going to put none for that one. Now for the next problem, let's clear that out. Take a look. And here's where, sorry, things are nice as far as online videos because you can pause and come back. And I only put all the answers on here ahead of time because I can't read my writing and I don't expect you to when I'm drawing on this tablet here. So look at number 2. Is going to say sketch this graph by hand and use the sketch to find the absolute local max and minimum values of your function. Now notice the domain that they're talking about is from x less than or equal to 3. So you only have to worry about from 3 this way. If I push that 1/2 through and distribute it, you end up with a function that looks something like this. And just to see what the y value was at 3, I plugged 3 into my function. So I plugged it in here. In other words, I plugged it in there, but I gave you the directions here. And when you work all that out, the y value is 4. So you notice here you have a value of 3, 4. So that's the highest it can get because your values are cut off by the fact that they have a limited domain here. So this is going to be your absolute max at x equals 4. And because this function goes down forever, you don't have an absolute minimum because hypothetically, you can keep going to negative infinity and then keep going. I'll tell you what, try number 3. Turn off or pause the video. And when you turn it on, I'll try to explain that one. Okay, So if you're looking at this, for number 3, it says find the critical numbers of the function for part A here. To do that, remember the critical numbers are where the functions equal 0 or doesn't exist. Now, because this is a polynomial, it will always exist. So all I have to do is pretty much just find the derivative, which is this function, 6x squared minus 6x minus 36, and then set it equal to 0 like I did there. Once I do that, a whole function set equal to 0, you can factor it. And using the zero product rule, you'll find that x is equal to -2 or x is equal to 3. Those are the critical values of your function. Try B. Turn the computer off or pause the video. And when you come back, I'll try to help you out. Okay, so this one I'm going to leave to you. Notice you can take the derivative, set it equal to 0 of this entire function, and then try to factor it out. For time's sake, I'm not going to factor stuff out at this time, but you can try to factor it out or graph with your calculator and see if you can guess values for the to find the critical values. In other words, where the slope is equal to first derivative is equal to 0. All right, keep practicing. Next page, I'll come at you with some more explanations.